The first and most obvious way to cool down a greenhouse is passive ventilation. By passive ventilation, I mean just opening a window or a vent portal of some sort. This sounds simple, but there's a lot of ways one can ventilate a greenhouse. And the type of greenhouse you have also affects what kind of passive ventilation system you can choose. For a hoop house, most will ventilate the end walls with a door or window and roll up the covering on the sides to allow for massive airflow to come through. Some heat can still get trapped at the top, but the vents on the end walls up high usually disperse this. Other styles of greenhouses usually employ a system of taking advantage on the principle of heat rising, using exhaust vents on or near the roof and intake vents near the ground. Regardless, the amount of cooling you can get with a passive system is limited to the outside air temperature. You can't get any cooler than what the air temperature is outside with a passive ventilation system. Now there's always an exception, and the one exception on a passive ventilation system of cooling the air below the outside temperature is with earth tubes. If you bury the intake vents and have the air run through the ground 4 to 10 feet down for 20 to 50 feet or more, the air will be cooled by the earth and drawn into your greenhouse via suction from the hot air leaving the roof vents. There is a limit though. The suction will only pull so much, and most people that use earth tubes as a cooling system on their greenhouse add a fan to the earth tubes to increase airflow. The more airflow, the more you can cool down your greenhouse. The other passive method for cooling down a greenhouse is shading material. This is a trade-off. The more you shade your greenhouse, the cooler it gets. But the more you shade your greenhouse, the less light your plants get to grow. Many shade cloths for greenhouses have been developed to reduce the amount of light but not completely cut it off. 25%, 50%, 75%, and anything in between are shade reduction amounts on shade cloths you can buy for your greenhouse from a number of places. These work, but understand that with less light you get less growth. Mind you, high temperatures inside your greenhouse will also retard plant growth, so you'll have to balance the percentage of shading you use for the best results. Shading is usually done with and needs ventilation, passive or active with fans, to properly cool down a greenhouse. Shading won't get the inside of your greenhouse any cooler than the outside air temperature though. This naturally leads us into the next step in ventilation, which is fans. You can blow the air around a greenhouse with fans, but it's when the fans are placed over a ventilation hole to the outside that you really start to get some temperature changing effects. How much this will cool your greenhouse depends on a lot of factors. The amount of air moved, outside air temperature, size of your greenhouse, cloud cover, how intense the sun is that day, all affect the system. Fans work, and after passive ventilation, fans are probably the most popular method of cooling down a greenhouse, private or commercial, in use today around the world. Fans in conjunction with shading material is how most greenhouses approach cooling their interior. Taking advantage of the energy used for a phase change in water is an option often used to cool a greenhouse. When water evaporates, it takes an enormous amount of heat to phase change from a liquid to a gas. Think of it like this. When you boil water, the temperature in the water slowly rises until it hits 99 degrees Celsius, at which point you see boiling bubbles and a lot more steam on top of the pot. But the water doesn't all instantly boil. It stays at 99 degrees Celsius in the pot. The water very slowly changes phase from a liquid to a gas in the pot, yet the same amount of energy is steadily being put into the pot from the stove. The water keeps taking this energy from the stove to boil the water. Massive amounts of energy over a long period of time until all the water is evaporated. This is the principle behind an evaporative cooler. Water is run over a radiator surface, it evaporates, and air is vented over that radiator, taking heat, which is energy, from the air as it evaporates, leaving less heat behind. This less heat is in fact a cooling effect, which can actually cool a greenhouse, or any building for that matter, lower than the outside air temperature. We call this an evaporative cooler, and they are common especially in areas with low humidity. Unfortunately, they don't work as well in high humidity areas. YouTube has several videos on different types of these cooling systems and how they work. Another spin-off of an evaporative cooler is misters or foggers. If you spray a fine mist or fog on the plants, in effect dampening the plant leaves, that water in the sunlight will evaporate off the plants and thus pull heat from the plants as it evaporates and cool down the plants. Often referred to as dampening down, this is a viable trick that can reduce the temperatures inside a greenhouse by over 10 degrees Celsius if you have a readily available, relatively clean water source on tap, cheap. Once again though, this works best in low humidity environments and doesn't really work in high humidity climates. Of course, if you have unlimited money or a way to get free electricity, you can use a conventional air conditioner. Large commercial air conditioning systems work and will cool the air, but it's a trade-off on cost to install a system like this and the electrical cost to operate it. Some public government greenhouses use air conditioners as cost isn't really an issue for them to cool the air. Yes, you can run an air conditioning system off solar panels, but an air conditioner large enough to actually cool a big greenhouse needs so much electricity that you would need a huge solar panel array, and that isn't cheap either. The massive overhead cost to this approach is why electrical air conditioners just aren't really used as a cooling method in private or commercial greenhouses today. There's other free energy methods like geothermal, where you use a radiant heat floor or radiators and running PEX tubing with runs underground 5 to 10 feet down, 100 feet or more long, that pick up the coolness of the ground and use that to cool the greenhouse. This is a lot like earth tubes, but using a liquid in PEX tubes to transfer the coolness instead of weeping tiles using air. Pumps are necessary, but these don't use a lot of electricity. And after initial installation costs, this system is actually quite effective and very cheap to run. Also, the same system can be connected in the fall and winter to a heating source to heat the greenhouse in a similar fashion. You can have a dual system for heating and cooling, or just cooling. What's nice about a geothermal cooling system is it's not dependent on having low humidity. A geothermal system works in high or low humidity climates equally well. Window film, or tinting, is usually thought of for cars. But if you have a glass greenhouse, window tinting is another option you can consider to cool your greenhouse, and it works very much like shade cloths, but with different materials. Like shading cloths, it's an issue in the winter, but unlike shade cloths, it's more difficult to remove between seasons. Winter greenhouses need heat, and the solar radiation heat is a huge boost for the plants in the cold seasons. Like shading cloths, there seems to be a trade-off with window film. The more heat reduction you get, the less light for plant growth. It seems the films reduce the type of light the plants need to grow. I see this as a growth market though in the near future, as science is getting better at filtering out specific light rays, so we will be able to reduce heat but still give plants all the solar nutrients they need to grow. Comment below if you know more about window films that can be applied to glass or plastic for greenhouses that allow plant growth. Bottom line is, a greenhouse can generate so much heat in the summer that if it's not controlled, it'll cook your plants and you won't be able to grow anything. Cooling your greenhouse to reasonable temperatures allows your plants to thrive, and the method of cooling you choose will depend mostly upon where you live, heat and humidity levels, and how much money you're willing to invest. Even when everything is done right, greenhouses rarely ever cool below the outside air temperatures. Ventilation with some shading sheets seems to be the most economical choice for most operations, private and commercial. If additional cooling is necessary, evaporative coolers are the most common choice in dry areas, and earth tubes or some sort of liquid geothermal system is the only real viable option in humid climates. I hope you enjoyed this video on how to cool a greenhouse. Where I live, we don't usually get sweltering heat. never much over 30 degrees Celsius. So ventilation is my personal choice, choosing larger fans over a shade cloth. But your location will determine just how much cooling you're going to need to operate your greenhouse without cooking your plants. YouTube is an awesome place to find an incredible amount of information on this subject. And you can manipulate YouTube's AI by talking to it so that YouTube's AI will actually suggest more videos on this topic for you. How you do that is by communicating with YouTube's AI. Hit the like button, share the video, comment below. When YouTube's AI sees you doing something, it thinks you want more on that topic. So it suggests more videos like this for you to watch. If you don't do something, YouTube's AI will suggest other things for you to watch. So if this video is something you want more of, do something. I'd really like to hear about what you're doing or your plans to cool a greenhouse in the comments below. Thanks for watching. When it's over, the fat guy starts singing and I'm about to start singing, so you need to go watch another video. Try one of these.